So today I like to discuss the this case basic latch using NAND gate. Yesterday we have studied the same thing using NOR gate. So these are two universal gates, NOR and NAND. So we will have to discuss the first latches using NOR gate, NAND gate, and then SR flip-flop by differentiating them. You see the first and simple, this one is your AND gate. This is your AND gate. Here it is two inputs, R and S, and here it is the output O. So the output O is high only when both inputs are high. And all other cases, the inputs are low. So these are the cases. In case of NAND gate, these are the two inputs, R and S of NAND gate. And the O dash is the output of NAND gate. So the O dash from the truth table, you know, the output is low. This output is low only when both the inputs are high. So we have to keep in mind these two important points, that in AND gate, the output is high only when two inputs are high. And in case of NAND gate, the output is low only when the two inputs are high. And in all other cases, these are the options. These are the options. So during operation, we have to take care of this concept. Now for the latch table, we see this is the R and this is S. And here it is Q and Q bar. So if both R is 0 and S is 0, so Q is 0 and 1, Q is 0 and 1, R 1 and 0. So these two are the existing state. These two are existing state, either of, and this is the circuit symbol of latch. This is R input with the AND, NAND, and here the other input of the NAND, you can say this is NAND 1, this is NAND 1, and here it is NAND gate 2. So output of 1 is fed to the input of 2, NAND 2 with S, and then we find this one is a Q bar. So Q and Q bar are these two outputs, and R and S, these two are inputs in the latch. This cross is known as latch. This is latch. So we take this 0, 0 as it is. Now this case, that is case 2. If we case 2, that is R is 0. For the clear discussion, let the diagram of this NAND latches. This one is R, here it is S. The input of S is connected with the output of NAND 1, that is Q, and the input of NAND 1 is connected with the output of NAND 2. This is NAND 2, this is NAND 1, and here it is Q bar. Now what we want, R is 0. This R is 0 and S is 1. R is 0 and S is 1. So what we find, any input of the NAND is 0. Any input of NAND is 0, you see from this, then output is 1. So this output is 1. R is 0, one of them is input 0, then the output will be 1. And if this 1 is the output and it is fed to the second NAND, so in the second NAND, both inputs are 1. Both inputs are 1. So the output will be Q bar. Output 1 and 1. You see, the fourth option is both inputs are 1 and 1. So the output is 0. So this value is 0. This value is 0. So what we find? We find here if R is 0 and S is 1, R is 0 and S is 1, then the output will be Q is equal to 1 and Q bar is equal to 0. Q bar is equal to 0. Now consider case 3. Again, we have to draw the circuit. This is the R. This is NAND 2 with S. And this one is the latch. And here it is the input of the first. This is NAND 1. Here it is NAND 2. This is the output is Q. And this output is Q bar. So for this third case, you see for the third case, R is 1. This is 1. And S is 0. This is 0. So you know that if any input is 0, if any input is 0 from the NAND table, the output is 1. So this value is 1. This value is 1. S is 0. The Q bar is 1. So this 1 is feeded over here. 1 is feeded over this part. And then 1 and 1, both are the input of NAND 1. So what will happen? Both the inputs of NAND 1, 1 and 1, then output is 0. So it is 0. So what we find? Q is 0 and Q bar is 1. So this case 1 and 0, that is 0 and 1. That is 0 and 1. And when both are 1, so both are 1, and the other step is cannot be predicted. So this one is unpredicted state. This one is unpredicted state, and this unpredicted state is sometime also called toggle. Sometime also called as toggle switch or toggle, something like that. So in this case, these two, that is case 2, this is case 2 and this is case 3. So this is S is 1, this is known as set, and this R is 1, so it is known as reset. So this is set and this is reset, and this is the basic latch working operation on the basis of NAND gate. So this is about the basic latch. Now we have to discuss about the SR. So before SR, we like to have the difference between the what is the difference between the flip-flop, differences between latch and flip-flop. This flip-flop is sometimes also F cross F. So the first difference is both are basically the bistable gate circuit. Bistable gate circuit. The second is latch. The second is latch is level triggered. Level triggered, and flip-flop is edge triggered. Level triggered means we see this one is the square pulse. So here it is high and this is your low. So high is 1 and low is 0. So these are the level triggered. High level high, and this is level low. And the age triggered means during the positive and during the negative. So this is the positive age. This is known as positive age, and this one is known as negative age. This positive age and negative is nothing but it is this spike, something like this. This is spike. This is the spike. So third point is both have positive and negative triggered concept. And fourth and last point is flip-flop. Flip-flop is a sequential gate circuit, which generally samples its input and changes its output only at particular instant. Instant means this is a spike of time while latch is in the time interval of level either high or low. So the time interval means this time interval. Time interval means this the time interval. So these are the differences. These are the differences between the latch and flip-flop. And these are the four differences. Major difference is the level operating, and here it is the age operating. And now we consider this one is on the basis of RS flip-flop. That is, let us consider RS flip-flop. RS flip-flop. This RS flip-flop is the circuit diagram. It is basically RS flip-flop using NAND gates with additional inverter, with additional enable inputs. It is also called as level triggered flip-flop. Level triggered flip-flop. Circuit can be drawn as, you see, this is NAND. Here it is another NAND, and this NAND is connected with clock CLK. In short, it is written as clock. This is set point. This is reset. This is the reset. And these outputs are again connected with the another set of NAND gates as in the latched state. This is Q. Here it is Q bar as the output. Q and Q bar as the output. So we call this is NAND 1. Here it is NAND 2. And these two are 3 and 4. Here this point is known as, you see, this is R, S and R. These are the basic latch. These are the basic latch that we have discussed just now. And for the operation of the clock, this is the basic latch. And here it is clock operation. This is the clock operation. The symbolic circuit, the whole symbolic circuit can be reduced in this form as this is S, this is R, and here it is clock CLK, and this is Q, and here it is Q bar. This is Q bar, Q and Q bar. So these are the two inputs, and here it is two outputs. So this one is SER, and this is Q and Q dash. Now, if we want to have the truth table, if you want the truth table, so we can have the truth table as this is input, and here it is the outputs, and then we have the comment. We have the comments. Now, in case of inputs, there is E, that is the clock, there is S, and this is R. This is R. The output is Qn, n plus 1, and here it is Q bar n plus 1. Q bar n plus 1. So this is the here it is Q bar n plus 1. Here it is Q bar n plus 1. Now the first case, suppose the clock is 0. This clock means something like this pulse. This is 0, and here it is 1. So if clock is 0, irrespective of the input at S and R, the output will have the previous value, that is Qn and Qn bar. This is the previous value, Qn and Qn bar. If the clock is 1, and both inputs are 0, 0, both inputs are 0, 0, in the same case, the output will be Q and it is Q bar. So we can say no change. This is no change as E is equal to 0. No change as E is equal to 0, and no change as E is equal to 1, because both are 0, 0. Because both are 0, 0. So this one is. Now, again, we see this is 1, this is 1, and here it is 0 and 1. Here it is 0 and 1. So if S is 0, in any case S is 0, the output will be, any case, output will be 0 and 1. So it is 0, and this output is 1. So this R is 1, so it is called at reset. It is called at reset. Here it is S is 0, so it is 1, and then it is 0, so this value is 0, and this value is 1. So this is reset. If clock is 1 and S is 1 and R is 0, if R is 0, this R is 0, so the output will be 1, and this is the 1, and then this value is, if it is 1, and here it is the 1, so 1 and 1 makes it is Q bar 0. So this Q bar is 0, so Qn is 1, and this is set. This is set. And if clock is 1, this is 1, and again it is 1. Both inputs are 1. So the, in case of both inputs are 1, the Q n plus 1 and Q bar n plus 1 cannot be determined. So it is known as indeterminate state. This is indeterminate state. So this is the truth table. This is the truth table of the RS. This is the truth table of this RS. Now we can have the explanation as well. We can have the explanation of this case as well. You can say operations. First operation is for E is equal to 0 and S is equal to R is equal to X, then the outputs of NAND gate 3 and 4 will be forced to be 1, and S dash is equal to R dash is equal to 1. The output of NAND gates 1 and 2 will unchanged. First. The second point is for E is equal to 1, and S is equal to R is equal to 0. The output of NAND gates 3 and 4 will be forced to be 1, and S dash is equal to R dash is equal to 1, the same as previous case. That is unchanged. No change. The third case is when E is equal to 1 and S is equal to 0 and R is equal to 1. And R is equal to 1, the output of NAND, gets 3 and 4 will be 1, and 3 and 4 will be 1 and 0 respectively. That is S dash is equal to 0, R dash is equal to 1. So Qn plus 1 is equal to 0 and Q bar n plus 1 is equal to 1, and then it is known as a reset. The fourth point, if E is equal to 1 and S is equal to 1, R is equal to 0, the output of NAND gates 3 and 4 will be 0 and 1 respectively. That is S dash is equal to 1, R dash is equal to 0, the Qn plus 1 is equal to 1, and Q bar n plus 1 is equal to 0, and this is known as set. And the last point is E is equal to 1 and S is equal to R is equal to 1. The output of NAND gets 3 and 4 will be forced to 0, 0, that is S dash is equal to R dash is equal to 0. Hence, it is undeterminate case, and it is avoidable. It is avoidable. So these are the conditions that we have in this case. Now